This lesson covers the factor theorem and the remainder theorem. And we're going to start out just asking a question that we can pretty easily answer with a graph. So it says, if this is f of x, which of the following is a factor of f of x? So I have x minus 4, x plus 5, x minus 5, and x plus 1. If I kind of look at this polynomial quickly, I can see that it's not something I'm going to be able to factor by grouping. I'm just not going to get that common binomial. But if I was to graph f of x, which is what I have right here, I can see that f of x has roots at -5, -4, and 1, which means I can also write this equation. I can see the lead coefficient is 1 as x plus 5, x plus 4, right, the opposite signs of the roots, and then x minus 1. So that's showing me that's the factored form of this equation. So I can tell that of these choices, x plus 5 is the one that's the factor. Looking at my table, if I didn't actually have the graph, if I look at the table, the fact that -5 gives me 0 tells me that x plus 5 is the one that's the factor. So that's from a table, from a graph. Now we're just going to check, well, does it work with polynomial long division too? So here I'm going to do f of x, which is my function up here, and I am going to divide it by x plus 5, and we'll see what happens. So let me just move this up a little more. I still want to be able to see my equation, so I can write it down. So I have f of x is x cubed plus 8x squared plus 11x minus 20, and we're going to divide that by x plus 5. Now, we've already said we think x plus 5 is a factor, so if we think about that, when we do the polynomial long division, we're expecting no remainder. So let's see if that's what happens. X goes into x cubed, x squared times, and then I multiply. If you want a more thorough explanation of polynomial long division, see the last lesson. When I subtract, I change the signs. So this is going to give me 3x squared, and then I bring down the 11x. Move it down a little bit now that we have everything set up. So now x goes into 3x squared, 3x times, and then I'm going to subtract again and change my signs. Cancels, and I have 11 minus 15x is -4x. Bring down the -20. So x goes into -4x, -4 times. So we have -4x, 5 times -4 is -20. So then when I subtract and change the signs, I see that everything cancels, and I have a remainder that's 0. This is tying together what we know about graphs, factors, roots, and then also now polynomial long division we're tying in. So it says, in general, if a polynomial p of x is divisible by x plus a, then p of -a equals 0. What that means is if I take a polynomial, such as this, and I divide by some sort of factor, x plus 5, it could be a negative, and then we just change the sign in the other direction, then if I went to the function, then the function's value at the opposite number, so if it's plus a, it would be at -a, is equal to 0. So it's basically just a way to test divisibility from functions. What we're going to write for this, basically, if a binomial goes into a polynomial function, I'm going to abbreviate that, polynomial function, the function's value at, I'm going to say the opposite number. We're trying to write it in words that make sense, you know, not a lot of technical math definitions. At the opposite number will be 0. So if we look at the next one, if we were to graph this on a calculator, It says if f of x equals x cubed minus 14x squared plus 43x minus 30, which of the following is a factor of f of x? So we could go through and divide divide f of x by each of the binomials that are listed below. So we could try polynomial long division, we could divide by this, and by this, and by that, and by that, and that would take a really long time. But the point is you can just look at the graph of this function and look in a table at the opposite values. So for this one, we would look at f of negative 10, this one at f of positive 10, f of negative 3, and f of negative 1. And the one that gives us 0, that's the one that's the factor. So I'm not going to pull up a calculator right now to do this, but imagine we typed that in a y equals, and then we looked in our table. F of negative 10 is negative 2,860. F of 10 is 0, f of negative 3 is negative 312, and f of negative 1 is negative 88. So none of the other ones are even close, right? This is the one, x minus 10 is the one that's the factor, and if I divided f of x by x minus 10, I would get a remainder of 0. It is divisible by x minus 10. Now, going a little further with this, we've done so much with factors, but we're going to think about what does it mean when something's not a factor? What does the function's value tell us? So we're going to actually start out with polynomial long division on this one. It says if f of x equals 5x squared minus x plus 2, then what is the remainder when f of x is divided by x plus 1? So we're going to go through what we would do. Basically, we're not super interested in the answer. We're just interested in the remainder, but we're going to go through the process of polynomial long division. So x goes into 5x squared 5x times, and we multiply it out, so 5x squared plus 5x, and then we subtract, and I add, subtract, and then subtract. So I have negative 1, this cancels, negative 1x minus 5x is negative 6x, and then we bring down the plus 2. X goes into negative 6x, negative 6 times, so I have negative 6x minus 6 when I multiply it out. Then I'm going to subtract and change my signs. This cancels, and I have a remainder of 8. Now, the question becomes, when we were on the other page and the binomial, for example, x plus 5 was a factor, the value at negative 5 was 0. What happens and what is the connection when I have a remainder? So if I look at the graph of 5x squared minus x plus 2, which is down here, and a table, if I look at the opposite value of x plus 1, that's negative 1, and I see the function's value is 8, which matches my remainder. And this isn't something that I think most people would come up with, but when we think about it, it makes sense. It's how far off are we from being a factor? So the remainder, if we're off by 8, basically the graph is 8 above 0, right? And it also makes it make sense why we can have negative remainders, because if the graph is below the x-axis, we would have a negative y value, which would correspond to a negative remainder. So this is the remainder theorem. If a polynomial p of x, so in our case we had f of x, it was 5x squared minus x plus 2, is divided by x plus a, then the remainder is equal to p of negative a. So what it tells us is that if a polynomial is divided by a binomial, so we'll write this down, and in this case, we're calling the binomial x plus a. So we were dividing by x plus 1 in this case. The remainder from the long division is equal to the value of the function at negative a. So that's the remainder from the long division. Is the value of the function at negative a. So if you need to listen to me, I know the handwriting's not great with my stylus, you can go back and listen to that definition. Now, why does this make sense, right? So we kind of already talked about this. I just talked about it before. Basically, I want you to come up with your own words for this, but what you could write is something like, if x plus a was a factor, p of negative a would be 0. The remainder is how far off it is. So I'm just going to write, if x plus a was a factor, p of negative a, so the function's value at the opposite number, would equal 0. The remainder is how far off it is. So we have another question here. So now the idea is we actually don't have to do polynomial long division. If all we want is the remainder, if I want to know the quotient, right, which is what number is up top. So the quotient in this case is 5x minus 6. The graph does nothing for that for me. But if I just want the remainder, if I just wanted to know the 8, I could actually graph the function and save myself the time from doing the polynomial long division. So down here, this question I'm using the same function, the 5x squared minus x plus 2. What is the remainder when that function is divided by x minus 2? Well, in my table, if I'm dividing by x minus 2, the remainder will be the function's value at positive 2. So we can see that on the graph, if x minus 2 was a factor, the point would have been down here, but we're 20 off from it being a factor, the remainder is 20. So down here, just to show my work, I would write f of positive 2 equals 20, so the remainder is 20.